Okay, so we're going to finish up the task here, the 3.5. I'm not going to cover everything. I'm going to go through this kind of rather quickly. It says use the open area model for distributing terms. I don't use the open area model, if you remember, because it ends up creating more work. But what I will do is distribute. So I get 15 plus 21i plus 10i, and then I get plus 14i squared. And whenever we see I squared, we always replace it with negative 1. So I'm going to do a couple things. I'm going to combine i's. So 15 plus 31i plus 14 times negative 1. And this becomes 15 plus 31i minus 14, and then 15 minus 14 is 1 plus 3i. So that's how you would handle those. As we move down, it says, if it'll stay there, it says these two complex numbers are called conjugates. What is a conjugate? We haven't heard of that term, although we've seen it before, because when you see something like 2x plus 3 and 2x minus 3, these technically are, we call them a sum and difference of squares, but they could be conjugates. They're opposite of one another. So what's the big deal about conjugates? Well, what happens with conjugates is if we multiply, we get 16 minus 8i plus 8i minus 4i squared. And what happens is these middle two terms disappear. So the imaginary part goes away, and I'm left with real numbers. How is that, you say? Well, 16 minus 4, and again we replace I squared with negative 1, becomes 16 plus 4, which is equal to 20, which is a whole number. So the number disappears. The same thing would happen if we did b over here, which I did in class. The next one, what we look at is, we cannot solve this. This is not factorable. It looks like it is, but it's not. You have to remember, the factors of 5, they must add to give me the middle term. So 5 minus 4, or 5 minus 1, rather, sorry, is equal to 4. That's true. But they multiply to give me c. And I put a question mark there above the equal sign, because 5 times negative 1 is negative 5, not positive 5. But up here it's positive 5. So I have to use the quadratic formula. I have to use the quadratic formula to go through and figure this out. Well, if I do so, x is equivalent to minus 4 plus or minus 4 squared minus 4 times a, which is 1, times c, which is 5, all divided by 2 times 1, which is a. And again, this simplifies rather quickly. You get minus 4 plus or minus the square root of 16. And I know I'm going through this kind of quick. Now, is it 16 plus or 16 minus? Well, a negative times a positive is negative. 4 times 1 times 5 is 20, all divided by 2. Therefore, you're going to get minus 4 plus or minus the square root of negative 4 over 2. Well, how do we keep track of the negative 4? So some doodles that I'm going to do up here is the square root of negative 4 is equal to the square root of 4 times the square root of negative 1. This is how we want them to separate this. This is the first time we're kind of seeing this. Well, the square root of 4 is equivalent to 2, and the square root of negative 1 is I. So I get minus 4 plus or minus 2i divided by 2. 2 reduces there, 2 reduces there, so my answer is negative 2 plus or minus I. And that's how we handle that. Complex solution, so it's still going to have a graph that doesn't cross the x-axis. Same thing would happen in 13, which we did in class. Not going to talk about that. And then the last thing we covered here is just simply paying attention to what it's asking you to do. Here it's asking you to add, because there's an add sign between. Here it's subtract, and here it's actually multiply. So this would be distribute, where we would get, the end would be minus 15 I squared, where the I squared would end up taking itself out. Oops, sorry. So I'm going to get 15I squared, which would be minus 15 times negative 1, which would be positive 15. Okay, so that's how that would work if we did that one. Again, you're supposed to do these. Okay, this is all part of your work. But these end up being a little easier. So that's it in a nutshell.